it's kind of insane to see just the amount of like activity and excitement around this space. Like there's, people training and fine tuning deep learning models that, weren't even in the space like a few months ago. And that's really awesome, right? And that I had like people who were like, oh, I really like guardrails, I really like OpenAI, but it's just too expensive for what I'm trying to build. And so can you make this work with, an open source model as an example? So I do think that we're going to see a lot of that proliferation happening of, great performing models from like different price points, different latencies, different providers, etc.
Hello, and welcome to the Cognitive Revolution, where we interview visionary researchers, entrepreneurs, and builders working on the frontier of artificial intelligence. Each week, we'll explore their revolutionary ideas, and together we'll build a picture of how AI technology will transform work, life, and society in the coming years. I'm Nathan Labenz, joined by my co-host, Eric Tornberg.
Hello, and welcome back to the Cognitive Revolution. Today, my guest is Shreya Rajpal, a former machine learning engineer at Apple and founding engineer at Predibase, who is now best known as the creator of Guardrails AI, a new Python library that allows developers to add a layer of output validation and correction to their code. As anyone who's spent time building AI-powered products over the last 2 years will attest, validation, and even more so, reliability, are key challenges. LLMs simply don't always follow instructions and sometimes go entirely off the rails. Better models have helped tremendously, it's true. GPT-4 can follow instructions far more reliably than earlier models, and Claude V 1.3 is also very impressive. But with this elevated capability also comes expanded developer ambition. And so it seems that for the foreseeable future, the problem of LLM reliability will remain both critical and ubiquitous. Shreya's work tackles this problem in many ways and at multiple levels. Super practically, Guardrails can ensure a reliable interface between language models and more traditional, deterministic software systems. Validations like, did the language model return data with the right type and format? Or did the model choose a value from the list of allowable values that we provided? These are very familiar questions for developers and are still powered in Guardrails by traditional code. But at the same time, and for me, this is clearly the more novel, exciting, mind-bending, and potentially risky use case. Frameworks like Guardrails allow developers to ask and answer entirely new kinds of questions. Assessments of things like the quality of a summary or translation, or whether a given piece of text contains any redundancies, inconsistencies, or gaps in logic. These are the sort of things that, until recently, developers simply had no way to validate. Thus, for product and engineering teams around the world, Guardrails is both a solution to a very practical problem at hand and a sort of introduction or bridge to an emerging paradigm of AI-first software development that goes well beyond the Copilot-style autocomplete or even chat interfaces that we've recently seen, and begins to use AI functions not just as development tools, but as components of the production technology stack itself. Talking to Shreya really reinforced for me just how early we are in LLM's impact on the software industry. The core AI capabilities needed to transform software, as far as I can tell, mostly already exist. What remains, though, is the work of reimagining not only how software is built, but how it functions now that intelligence can be baked in at any point. Personally, I believe that this paradigm shift could ultimately unlock bigger productivity gains and more user value than the current generation of tools that increase developer speed, but don't yet attempt to change the kind of software that they're building. At the same time, this is also something to be approached with real care and caution. The delegation of AI output validation to other AI models is not a step to be taken lightly or taken for granted. I hope you enjoyed this thought-provoking conversation with Shreya Rajpal of Guardrails AI. Shreya Rajpal, welcome to the Cognitive Revolution.
Yeah, really excited to be here. Thanks for inviting me.
My pleasure. So this is the first time that I've invited a guest. Basically, as soon as I got off the call recording a previous episode, it was Matt Welsh, CEO of Fixie.ai, who mentioned your new project, Guardrails AI. And I was immediately like, okay, I have to learn everything I can about this. So I'm really excited to dive into it with you. I guess let's start with what made you say, a couple months ago, I need to build a system to help people keep their language models on the rails.
Yeah. I think I was really solving my own pain points and my own problems. So I had been end of last year, I'd kind of been like doing some tinkering on my own where I was building some applications. And even as I was building them, I was like, yeah, this is really cool. I think it was nothing very exciting, a lot of like what you're seeing on Twitter about, chatting over proprietary documents, etc. And I was building that and I realized, yeah, this is pretty cool. I can see the potential with this. But even as I'm kind of like, as a developer, like testing it out, like I can tell that it doesn't, get me reliably the desired experience, the experience that I want, to achieve. And so I think it was this big problem where these language models are really potent and they're really powerful, but they're also, inherently very stochastic and very hard to control. The other kind of like what makes this very interesting is that like unlike traditional machine learning, how this is different is that as a developer you haven't really trained the model, so you can't just throw more data at it, like make it work really well for your use case. And then separately, the only knob you really have as a developer is like here's this prompt. And if you wanted to, like maybe do something or not do something, like how developers typically deal with that is just, adding like a lot of verbiage in the prompt and maybe a lot of like exclamation marks, etc., to like make it listen to you, right? And that just seems like woefully inadequate. And so Guardrails is this idea of, a specification framework where as a developer, what the right output for an LLM looks like, and you're able to, like decompose that and deconstruct that and, individually validate and verify each component of that output. And then, if any of those components fails and if any of those quality criteria that you impose on it fails, then, it gives you a set of tools to address that in a very extensible manner. So I was building this and I was like, yeah, I know what responses I want a user to be able to get from this thing that I'm building, and how do I ensure that, I'm always able to do that for a wide variety of scenarios. And so that was kind of some of the inspiration. It also, it spent some years in, autonomous systems and self-driving. And, it's a similar problem there as well, where you have this like really powerful deep learning based perception model that often feeds into, this more a more rule-based like decision-making system. And how do you essentially ensure that the interface between that stochastic system and that deterministic system is, robust and not brittle whenever like the perception system like maybe doesn't do as well. And so the idea was, to like, it was inspired by like some techniques you'd kind of see there, but like built for language models and built in a very extensible way so that it's not very domain specific. That was some of the inspiration. Yeah.
As much as possible, I love to get super concrete on these things. This is clearly a pain point that a lot of people have. The project has, gone on its own little rocket ship ride of GitHub stars with 1,200 as of last check at the time of this recording. But probably a lot of people listening also could use a little bit more of like a concrete example of like, okay, what kind of thing are you looking for and how is it failing? And then, can you kind of tell us maybe a couple of those, and then how does the guardrails, come in and save the day in those instances?
Yeah, absolutely. I love that question. I love digging deep into the details, so I'm happy to do that. I think when I was prototyping guardrails, my favorite like kind of prototype example was that I have this, Chase credit card agreement, which was like my own credit card agreement. And I want to extract like what are the key terms, etc., from that credit card agreement, get a nice JSON out of it. And I want like as a user, I know that, okay, if I'm extracting something like an interest rate, it must always be a number, it must be maybe a percentage sign in it, like what is a reasonable range for that? If I'm maybe extracting like the name of like a specific fee, and I want this name to be presented somewhere, I know that the name should be, very, very concise. It should be like very verbose, etc. So I think like one of the so the common failure points, etc., there is that like if I want to extract this information and then it needs to be like maybe added to some downstream data sync, like it's hard to do that reliably, consistently from an LLM, because an LLM doesn't behave reproducibly essentially. So in this like structured data extraction setting, I could essentially enforce constraints of like what I want each extracted entity to look like. So for example, the interest rate must be a number, must be within risk range. There must be a description with each interest rate, and the description maybe needs to be some length or some needs to be relevant to like whatever the entity that it is coming along with. So I think like all of those constraints are like what I want to impose on this JSON structure. So that was a use case that I was prototyping it. I think since then I have a ton of examples on my documentation, but like one of my favorite ones is text to SQL. So in text to SQL, it's like a wildly different domain, but a lot of the same ideas apply, which is, that you want correctness from any generated like SQL query. So the idea is that as a user, you want to be able to ask natural language queries over your data and get like a SQL query that you can maybe execute, right? So a lot of the ideas are the same, which is that, you need to be able to like, what are the constraints you want to be able to impose a priori on that SQL query? So it must be, it must actually work for my database, for the environment that I want to execute this query, and other constraints, right? Like you may not want to return results from any specific, tables. So some tables might be private. And if you want to say like, as a customer, you never want to be able to, like query those tables, you can like filter those out. You can add things like only support these specific SQL predicates. Like if there's any like drop predicates or, like maybe update or insert predicates, you want to be able to filter those out. So the idea is that you can like, as you're setting up this text to SQL task, you can like add all of those constraints. So how Guardrails solves this problem is it takes your database schema and sets up a SQL sandbox for essentially like any SQL query that is generated, it's executed in that sandbox to make sure that, it's executable. And if it's not executable, you take all of those errors for why the SQL query fails to execute and like wrap those errors into something, send it back to the large language model to, like correct itself and get something that actually works for your specific database. And then you can add like other constraints and other restrictions on top of that, like similarly, like filtering out specific tables, filtering out specific predicates, etc. So I think just this idea of like, here's a question, here's like a task I want this large language model to solve, but as a developer, I have like some domain expertise for what correctness means to me in this task and how much I care about that correctness. Like, is it, if it's incorrect, then this query is totally useless to me, or if it's incorrect, I just want to know about it and maybe post hoc I'll handle it. Like I think that is the main kind of like idea, and Guardrails like takes that and allows you to like basically implement that as a developer. Yeah. So hopefully that was a little more grounded in terms of specific examples.
Yeah, it's fascinating. One of the things I want to kind of explore the most in this conversation with you is the seemingly we're like opening up a spectrum or a dimension, if you will, where we can kind of go from, on the one end, like explicit errors, like the errors that we are used to as developers in code, and that could be starting with a syntax error, up to more meaningful errors, like, but that could still be sort of found through kind of traditional software messages, like this variable doesn't exist, or all sorts of things like that. But then you've got kind of a whole domain of correctness which code has never really accessed before, and that is like, what are you trying to do? Is this does this appear to be a reasonable like approach or output, or from a much more sort of semantic or, dare I say, like intelligent point of view. But I find myself a little confused or a little bit like lost in that space. And I see that you're kind of covering it in a really interesting like mix of ways, right? In the library, in the validators, there's a mix of validators. So maybe kind of walk us through, tell us how you think about that, I guess. And again, maybe some examples of like different validators that sit in different, parts of that space. Would be helpful to help people understand what the hell I'm talking about if it's not already clear.
Yeah, no, I think that was kind of like one of the very exciting things about the library as I was building this out, which is that, the general framework works even outside of things you can't, like maybe use like an assert statement to verify or something, right? Like it's really extensible as a framework where you can have a mix of, large language models and maybe some rule-based heuristics, some programmatic checking, as well as like more traditional machine learning models that are, very maybe high precision classifiers, etc. And you can like ensemble all of these techniques together to get something that is, greater than the sum of its parts and like much more robust and much more reliable compared to just using a pure large language model. So as an example of that, like I last week added a bunch of guardrails for summarization. So if you're, summarizing like multiple documents and maybe generating like an aggregated summary from that, there's a bunch of like requirements that you may have in order to ensure that, that summary is accurate, that summary is, concise, it's not redundant, etc. And so how Guardrails kind of thinks about this general problem of correctness when assert statements aren't sufficient is to like really break it down into like either smaller ML tasks or into smaller like verifiable heuristics, etc. And tries to like get an aggregate assessment of like how well this works.
Hey, we'll continue our interview in a moment after a word from our sponsors. I want to tell you about my new interview show, Upstream. Upstream is where I go deeper with some of the world's most interesting thinkers to map the constellation of ideas that matter. On the first season of Upstream, you'll hear from Mark Andreessen, David Sachs, Balaji, Ezra Klein, Joe Lonsdale, and more. Make sure to subscribe and check out the first episode with A16Z's Mark Andreessen. The link is in the description. Omneky uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omneky so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.
So in the case of summarization, what that looks like is if you essentially want to figure out if this summary is, like faithful to the original source text, how you can do it is like basically look at like each sentence in the summary. And then, essentially do something like a similarity matching based on, like which parts or which passages or sentences it's most similar to in the source text, which allows you to do much more fine-grained attribution and figure out, where is the sentence that it generated coming from. The other cool thing that you can do on top of this is that you can assign thresholds. So as a developer, you can like do some experimentation, figure out what is my appetite for, how varied I want these sentences to be from the original source text, and then set a threshold. And then any sentence that is below the threshold in terms of like similarity score, you can essentially like filter out. And like not include that in the summary. So that allows you to. I think it's just this way of thinking about text outputs, which may seem like like a single unit, and it basically kind of like breaks them down into like smaller chunks and independently tries to like verify that. So I think like other techniques you have in summarization specifically is make sure that there's, I want the summary to be concise. So make sure there's no like redundant information. So essentially within the generated summary, essentially make sure that like each sentence is diverse enough from, like other sentences within that. And if that's not the case, maybe like filter out, sentences that are too similar to each other, etc. I think like the cool thing about LLMs, it's like, we are looking at like a lot of the first order benefits of that, where you can use this and do like a bunch of like really insane tasks. But I think the second order benefits are that you can really use these models as verification systems, in and of themselves. So you can like use a large language model within a validator to like, verify and validate like whatever you're getting is correct. Or you can use, depending on your access to data and your like latency requirements, etc., maybe train like a smaller ML model that kind of does this for you. But like truly like bring together, a bunch of these different verification strategies and then get something that's more robust. So that's the philosophy behind like how Guardrails tries to, add guarantees around like what traditionally seem like harder ML problems to verify.
Yeah, that's really interesting. I'm mapping this onto my own use cases here in real time. So I'm wearing my Waymark swag today. Waymark is in the video creation space, and we have, it's a multimodal problem, right? Where we ultimately take in some minimal information about a business and then ask the user to tell us what they want to create. And then on the other end, provide a ready to watch video. We kind of do that with like an ensemble of different models working together, but the core one is the language model that writes the script and kind of gives the direction for what the visual assets should look like and all that sort of stuff. And I mean, for one thing, boy, we've come so far in a year. It was just a year and a half ago, basically, that we got the very first fine-tuned GPT-3 to do the task at all, with any sort of like, it wasn't good, but it would at least like respect,
the nature of the inputs and outputs. And now today, GPT-4 can basically do it zero shot and like respect the outputs. And then 3.5 turbo kind of not really reliably. But then I think, geez, it is like 20 times cheaper. So I guess I'm interested in kind of what do you see the value drivers being for this sort of thing? To some degree, maybe like there's no other way to do it. But as I'm kind of running through my head, I'm like, so on some of these things, like GPT-4 is pretty reliable at this point. So people might want to do it for cost savings, or they might want to do it for, I don't know. I guess a lot of different reasons. But cost savings and latency are actually one I would see like benefits to that potentially if I could move to a little bit of a less reliable model, but still like know that my stuff is going to render in the right way for our users. So what are you seeing in terms of like the value drivers from your community?
Yeah, I think that's a really great question. So I think there's two aspects of it. So cost and latency, maybe being able to use like open source models or, like cheaper models with like the same level of reliability, etc. I think like that is like one aspect. But the more interesting aspect for me is, like what is the task that you're truly using this model for? So, like Waymark, there's a lot of use cases where you're using these models as maybe writing assistants or to, like help you. One of the products I enjoy using is like Notion AI Assist, I think is what it's called, where you draft a little bit and, it helps you like maybe shape up an outline, etc. So I think for those use cases, the creativity of a large language model is actually really good and it's a desirable trait. But I think at the same time, there's this whole other space of use cases that are, that rely on the world model that is, ingrained in these large language models, and it uses these large language models as like software abstraction to do more general purpose reasoning. So I think there's a wide variety of those use cases that I've seen. So for example, like one of them is that use an LLM to basically as like an AI receptionist, essentially, where you're a small business owner and you, instead of, needing to hire a receptionist, you can use a large language model, and anytime you get calls, it, figures out scheduling, figures out who's available, etc. So that's a very powerful capability of that model where, creativity is maybe not as good a thing, right? Like you want it to maybe stick to like some desired workflow that you want to be able to ask. You want to make sure that maybe you don't ask for private information if, like a customer is calling, etc. So I think like where Guardrails is like most useful is within those constraints where you use the LLM not just as a text generator, but as like a software abstraction, really. And when you're using it in that capacity, that is when like reliability becomes most useful. I think over the weekend I'd shared something that a community contributor had built using Guardrails, which was this GitHub action called auto PR. And what auto PR does is it takes a GitHub issue and then automatically creates a pull request from that GitHub issue like for your code base. And that is one of those use cases that has like a bunch of really strict constraints, right? Like these files must exist, the code, the diffs that are generated must be valid for those files, etc. And those constraints are pretty hard to enforce like without having some validation framework such as Guardrails on top of it. So I think like for a lot of those use cases, like creativity is like not as nice a thing and you want like more reliability. And I think like it's still like such a powerful use case of this model that it would be, we would be kind of underutilizing their capability if we don't build software such as that, Yeah, it's a mix of both. I think even with a lot of the creative use cases, I've kind of found that there's still like a bunch of constraints that, people implicitly have that, right now the way to do it is like via prompt tuning or prompt iteration, but truly being able to, like encode these constraints and like maybe only like instead of like manually having to do this, like have a validation that runs and then, only do it like when needed is like also a pretty nice workflow where you, for example, you might not want any profanity in like scripts that are generated, or you might, if you're creating like video content for someone, you might not want to mention, peer products or like competitors, etc. And so I think like those kinds of constraints are also, like useful even with free form text. So it's a mix of both.
It sounds like though you are most excited about something that could not be achieved in traditional code. And I still kind of am really trying to find that line, or like, I guess there's maybe just a lot of overlap a lot of times when I get to these kind of puzzling moments as I study different aspects of AI, I end up kind of finding that it's like sort of both in the end. And there's probably a lot of truth to that here too. I'm thinking, okay, so we're in the GitHub, the automatic pull request, auto PR it was called, right? I saw this. It is cool. And super technical. To some degree, those responses could be validated, presumably by like existing libraries. Like I'm sure, the Git package itself has like some way to sort of say, you ain't got your shit together, so, this is not going to work. And I think that's kind of what a lot of people are like naively doing is, just kind of implementing that stuff on a case-by-case basis. Like at Waymark, there is no standard. Nobody else has our video standard. Like we totally define it and own it. So, it was up to us to figure out how do we represent that in text and then like what validation comes back from that. So I think one thing we could maybe have tried to do is, we did this before you launched the project, but I kind of wonder like if you're advising us, and we were maybe a little earlier, how would you think about like what points of validation we might, ought to do through guardrails? Like, should we be thinking about structure, or should we be thinking like, does this copy like satisfy the user's prompt? Or, I guess there's probably a lot of room in between, right? Those kind of stake out the like most rigid versus most kind of semantic, desires or requirements from the model. It seems like you're more interested on some level on the semantic side, but that there is this kind of like fundamental interface with computing where it gets like very syntactic as opposed to semantic as well.
I think it's a good question. I do want to say before I say this, like I want to preface this by saying that like generating something and getting outputs, getting feedback from the end user about, is this good? Is this like, does this meet your original criteria? And doing a more like qualitative assessment, taking that feedback and, going back to the drawing board. I think that's a very valid way of doing things, right? Like I think for a lot of domains, like getting that human feedback and getting that human input and write-off is like essential before you can like truly think that this output is correct and is valid for, whatever use case you have. But I think like for like in the guardrails world, there's basically this idea that, maybe some parts of that human feedback can be done by a combination of, traditional ML, heuristics, and maybe more large language models in the loop, right? And if you are able to, like take some of that, encode whatever that qualitative criteria is into, like codify it into something that is more specific. What you're then able to do is, like generate specific like failure, error messages, etc., that help the model output correct itself, right? So in terms of like maybe how that would I obviously don't know as much about Waymark, but what that might be helpful in is, like maybe doing the number of like back and forths you have to do with your end customer, because you're just able to take some of their constraints, run those programmatically. If they're wrong, like automatically create like new prompts that, tell the large language model why previous outputs are incorrect and get it to correct itself. So I think this is like one of the net new capabilities that we have, with large language models that didn't exist previously, which is, their understand, like the ability to get them to like self-heal or self-correct themselves if you give them enough context. And that is where like guardrails, like I think a lot of the like core functionality for guardrails, like really harnesses that, right? So how it functions under the hood is like it's really good at, figuring out like what the relevant context is, like packaging it up nicely, automatically creating a new prompt for you, getting a new response from the large language model, merging that new response, with the old response that you had, because it's very efficient. It only re-asks like things that are wrong, not like your whole previous output, etc. So it merges all of that together, and then that is your corrected, validated response. Sorry. So I think that is the world where like guardrails is most useful. With that said, it is very domain specific, right? Like there are domains where, let's say it's something like any text that is generated must be funny. Now that is something that is like next to impossible to validate. And I can't imagine like writing a validator that maybe assigns like a scoring function to humor, right? Like that's just very hard to do. And so you can't do that. And you need to have like a human in the loop. Maybe there's like some other domains, right, which have like very high stakes and very high cost to like getting something wrong, where even if like maybe you can do some pre-scoring, etc., the actual like human, a confirmation that this output is correct is like essential before you can do another like iteration with the large language model, etc. So there are those domains where this re-asking strategy doesn't work, but I do think just this idea of like taking what is correct, like what is correctness, or what does like an aligned output mean in your use case, and trying to like codify some of that is useful, both in terms of like prompting the large language model. It allows guardrails to construct like prompts that are more effective at getting you what you want, and then it also allows you to do like post hoc validation and this like loop of I want to systematically, programmatically handle failures as and when they arise, and maybe that involves like re-asking, maybe that involves like filtering any like incorrect output, etc. I think this is a very powerful framework to like require less human supervision and like take a lot of that pain away of like maybe going into ChatGPT and like writing like, okay, this didn't work for this reason, and trying to like write something else. So that's a world in which like that's the hypothesis behind guardrails.
Maybe it's just because we all have agents on the brain, but as I'm listening to you describe that, I'm really going to this agent, moment that we're in, and sort of really when you dig into these agent systems, it's usually like, you might think of it more classically as like a multi-agent system. In many cases, like it's the same language model playing the role of different agents. We're seeing all these examples where it's like a simulated town where, GPT-4 plays all of the people, or, a research agent where there's like a planner and a coder and a, retriever that all kind of work together and have their own prompts, and they're all kind of scaffolded together. And then, of course, these things fail a lot because they are, there's some probability of being wrong at any given point in the chain. And then you're only, in the naive implementation, you're only kind of as strong as the weakest link in the chain. So in a sense, I guess what I'm learning here is like this guardrails paradigm is like connective tissue between the different roles in a like multi-agent system. And I should probably accelerate how quickly I think that these agents are going to start to work. I think
agents are very exciting. Like I think I've been thinking about them a bunch and trying to think about like, how do you make them more effective, more reliable? I think the interesting thing about agents versus how guardrails works is guardrails is, essentially the main problem that is solved is like, I want to add constraints on this output so that it works for my use case, right? It works for what I wanted to work on. But essentially it gives developers a lot of agency to think about, like the specific problems that they're solving, and what correctness means to them. I think like contrasting that with with agent frameworks where a lot of the goals of agents and a lot of the tasks of agents are like configured autonomously, like by a large language model itself. So you're in this like interesting setting where the involvement of a human or a developer in terms of like your ability to kind of like enter something like an agent framework and like add guarantees, etc. You typically, like with the agent frameworks that exist today, you typically don't have access to that fine-grained level of a task execution or goal setting, right? Because you're not the person who's configuring these agents themselves. So I think like there's this So I think like that is that gap between like how agents operate today versus what humans would ideally like to have. Like ideally, if you're a person who wants to like employ a bunch of these agents and maybe do research for you, etc., you want to be able to say like this is the set of allowable things that you're able to look at, but also you want that to be configured dynamically based on like where agents are operating. So I do think that like. So that is the context. And if I were to summarize into like what that means for, agents, I do think like constraints are essential and like correctness specs are essential, right? It's the only way to think about like, how do you assess what these large language models are doing? Like you constrain them and you evaluate them at each step to make sure that they're not going off the rails. But like, how do you do that dynamically when you're not the person who's creating these agents, setting their goals, etc.? I think like that is the key problem to solve there. So yeah, it's a problem I'm very excited about, and I think it's a problem that will need to get solved before these agents are like employable, before you can truly use them, outside of just like seeing how exciting they are. Yeah, I guess like for agents, I'm always very curious to see people's use cases. So like for Waymark specifically, where once again we're like in this domain where there's like constraints and there's like a finite scope of like what you want the large language model to do, etc. If you've like looked at some of these agents and thought about like what is something that you would want to like add into what part of the Waymark stack could be aided with like agents.
Yeah, it's probably not such a great fit, I don't think, for the Waymark product experience, because we do have a lot of structure. I kind of think of these things as, I'm still working out this framework, but I talked about this with Matt, actually, and this is part of what led to him mentioning your project. So we're kind of bringing it full circle. But I kind of think of different, I don't know if this is a spectrum or a binary or multiple categories or what exactly, but in terms of like how we interact with AI systems, there seems to be a like real-time co-pilot mode where you are doing stuff as a human and the thing is like there to kind of guide you, shepherd you, whatever. And then there's things where you're kind of ultimately delegating more because you really don't want to do it. You don't want to be the person in the driver's seat or the entity in the driver's seat. You want to put the AI in the driver's seat, let it do it, and then look at its work once it's done, or have some other sort of way to like circle that back into your life. And those workflows right now are largely done with like integrations, various kinds. That could be code, no code, Zapier or what have you. With Waymark, it's code. And it's a pretty guided experience where like, you are delegating the task of writing a script, choosing all the assets for your video, etc. And then what you get to do is watch the output. So there's so much structure there that it doesn't feel like we really need an agent to like come in and, mix it up too much. But I do see the agent as sort of the bridge between these two modes where you're like, in real time, I sort of want to send something off. So if I'm in ChatGPT Plus today, I can like use a plugin perhaps to look for flights, but I really more might want the thing to be like, go book me the flight for, whatever date, like subject to my preferences. And ideally, like it would kind of figure out all the downstream mess of that. So where I think this is actually really relevant for me, so I'm also working with a company called Athena, which is in the executive assistant space. I also talked about this with Matt. And, they have those kinds of things all the time where, a human today is like responsible for executing a lot of web tasks, for a client. And there's kind of, different aspects of the cognitive work there. One is like understanding what's going on, like translating the language to from the client. Like you got a request, right? What does it mean? Understanding what it means. And then the other part is like being able to like actually hit the right buttons to make it happen. And ideally we delegate that whole thing. But the agents, that's where in our kind of testing, like along with everybody else, we've kind of found, it's not, we may have AI that can understand the request, parse it effectively, ask the right follow-up questions, or at least suggest some pretty good follow-up questions, demonstrate a really robust understanding of like what the human wants. But we're falling down very much still on like, how do you actually, hit the right buttons, check out? I mean, God forbid you have to like do a payment, process, or like log into something.
Yeah.
Like two-factor authentication does still work as a deterrent to AI login, for the time being, at least.
Yeah. I think that's kind of been like my experience, and my exploration as well, which is that there's this interesting like wedge where agents can be useful, but in order for that wedge to succeed, you need this notion of like grounding, right? Of like being able to like figure out like, okay, here's how it understands what I'm saying, but like at each step of that execution, you need validation. So I think this idea or the problem of like, okay, book me a flight is like very interesting, because book me a flight, like given my schedule and given my budget and where I'm trying to go, right? And that translates into maybe like some constraints that are then grounded, like based on your calendar or based on your, based on like where you're trying to go and like what flights are available. And so I think like validation at each like decision that the large language model makes and each action that it makes like becomes more important for these things to succeed. But at the same time, like having worked in like the self-driving world a little bit, like part of it is like, are they able to do it, and part of it is like, can a human there's this like trust deficit, right? Where even if these agents were perfect, there'd be this trust deficit between how much people are comfortable, delegating. And so even in terms of like building that, you need, you need this like verification system essentially that makes sure that each step of the way you're able to kind of like have control and have some oversight into like how they execute themselves. So I think those frameworks would be kind of like essential before we're able to see their adoption, outside of like demo use cases.
Yeah, it's funny that you say that. I would actually take the other side of the bet there when it comes to the human behavior. I mean, if I understand you correctly, you're saying people won't want to trust these systems unless there's good guardrails in place. I think of you as saving people from themselves, because I think people are going to be much more quick to just kind of go ahead and be like, yeah, it seems like it works. And why, what's the worst that could happen, right? And I think we may find out, especially, in a future world, that the worst could be potentially quite bad, but I do kind of expect that behavior. I just recorded an episode with a medical school professor at Harvard, Zach Kohani, who has just written this book, The AI Revolution in Medicine. And, this is exactly, I think, the kind of system that he's looking to figure out how to implement into clinical practice, right? Something to kind of help, for now, it's like, of course, the human is in the loop. That's the official recommendation. But even then, it's just so easy to get lazy. It's so easy to kind of be like overly trusting, especially when the models are getting so good. It's fascinating that you can get better performance just by kind of pointing the model at itself. That's one of his big findings. Was a recurrent theme is that GPT-4 is better at evaluating text than it is at generating. And so, he's starting to develop some of these like self-critique things totally on the fly, like in the context of, just exploration in clinical setting.
Yeah, I think that's part of like what Guardrails, like the validation system, is also based on, which is that, like it's almost like trust but verify. Like you get GPT to generate something, but maybe have it even if you are doing large language model based evaluation, maybe like have a separate step that does evaluation separately, so that you have that additional layer of security. And ideally, this is back from machine learning, but like the more diverse evaluators you have, the more kind of like guarantees they're going to be. So just like ensembling is a technique that I'm pretty bullish on in this space. It's like what's going to get us that confidence. But the medical like AI for medicine or medical assist is so fascinating, because it's back to like reminds me of like once again like self-driving, where like with the autonomous vehicles that are out there today, maybe like Tesla, FSD, etc. The idea is like, okay, you're still supposed to be very alert. You're not supposed to take maybe your hands off the wheel or something. I don't have a Tesla, so I don't know. But even within that, there's this expectation that a human should always be aware and like present, etc. Right? But like as humans, it's so easy to get lazy. And so one of the things I'm really excited about in the space is like good interface design, so that like we are able to like get human involvement when it's most needed, and like not like if you're always notifying them like, hey, pay attention, like maybe that like ceases to have an effect, right? So it's this idea of like, okay, how do we build this balance between like when human involvement is necessary versus like when we can like maybe offload some of that, do that more programmatically or more with code. I think like figuring out that balance and figuring out the interface to surface that balance, or surface that like a division of responsibilities to the human. I think like that is very very exciting, and very, very excited to see like how that evolves.
I don't have a Tesla either, by the way, but a neighbor of mine does, and has the full self-driving package. So knowing that I'm as obsessed with AI as I am, he was gracious enough to take me for a ride. And first of all, it works way better than people, I think, commonly realize. Like, I got into the car in front of my house. He put his finger on the screen. We're going to go here and hit the drive button. And the car drove. Like, there was not a lot of fuss between just, map, go, and you're riding. But when you talk about like the reminders, that's something I think they've really put a lot of engineering into as well. Like, there's like 3 progressions. I haven't spent a ton of time with it, but there's a couple of, I think it's 3 levels of. First, there was a little maybe visual indicator that like you haven't done anything to the wheel in a while. There's a camera also that watches you from the rearview mirror in some versions. But then after that, it goes to a little sound, and then after that, it goes to a warning, and it's like, we're going to pull over if you don't keep your eyes on the road. So they're pretty far along in that, and I thought that was a really remarkable experience, because it is a very delicate balance. So easy to tune out. Obviously, they have the hammer there eventually of like pulling over. And eventually they also will kick you out of the program if you pull over too many times. He said, if you're truly sleeping at the wheel, they'll retract your access to FSD ultimately. But it is a fine balance, right? Because you can start to tune these things out. So, I mean, how many warnings do we tune out? Crazy. So the next big thing that's kind of jumping to mind is, okay, you've got this developer, like, what is right to me? But the pattern seems to be very quickly like, well, why can't an AI just do that? So I start to then think, like, is there a version of this that's like a plugin? Like, you've created a spec, and I'm trying to envision what is it like to use a computer, a year from now, as kind of the tooling and the plumbing all matures. One good candidate would seem to be like, it's a chat interface that you can like access the world through and delegate stuff to little agents that go, do stuff and report back. It sure seems like a GPT-4 central process could like use the guardrail spec or something similar to, kind of insulate itself from problems as it like delegates things off to the side. So first of all, do you see that as realistic? And do you have a point of view as to kind of how the computing experience might evolve in light of that?
That's a very, very good question. I think I can go in like a bunch of directions like in my answer, but I think like my core belief like for that in that whole space is I think like humans will be very essential in the loop. And so it will be very hard to automate like all of this away, right? I think primarily because even what correctness means like very different things to different people in different contexts, right? And so one common thing as an example is like profanity filtering. Profanity filtering is like one of the things that like most people can get consensus on is like maybe if you're generating text, like make sure it doesn't have profanity. But I've also chatted with people who are building like chatbots where the chatbots are interacting with like certain audiences, and like authenticity is essential, right? And so if the chatbot is trying to imitate someone or like be in the likeness of someone who does use profanity, then filtering out that profanity is actually detrimental to the user experience that they're building. I think it is very hard to figure out like what those constraints are on a global level. And so I think like having humans and domain experts like be involved to developers to kind of figure out like, okay, like think ground up from like what they're building, what they want to use, for users to even think about like what is their desired experience. I think like those inputs will like continue to be very important, and like there would need to be like some way to configure those inputs or those criteria or just that experience that like a user or a developer wants. So I do think that like I guess like offloading this entirely to the model or to like a provider, is like going to be hard to be able to achieve, like because of that constraint. But in terms of like what the programming experience, what the developer experience could look like, I think one way, and this is like purely hypothetical, I'm not making bets on this at all, but like one way is to like really start thinking like almost configuration first, right? Like there's like a configuration system that allows you to like, tune the outputs that you want to see from these LLMs. And even if the underlying machine learning model stays the same, like how that model is like validated, corrected, like how the outputs of that model are post-processed, like that is all what you can configure. And so when people are working with large language models, it's not just text, it's also this configuration that they kind of pass in every time. And this is like, I'm an engineer, and so all of my empathy goes to like engineers whenever I'm thinking of like building systems, etc. So especially in engineering, like this is a pattern that I do think will be like pretty important, where the prompt isn't sufficient by itself, and just choosing the LLM and choosing temperature or something isn't sufficient by itself, but it's this configuration framework of like how do I want this output to be like, and even like how do I want my input to be like processed or formatted, etc. So that is like one pattern that I would kind of see emerge.
Yeah, security also jumps out to me as like a big driver here, because as I was thinking about where would I use this and all the things that I've done, I'm kind of like, increasingly I see like GPT-4 just running pretty well and giving me like the format that I want. Certainly it has, plenty of errors, but it very rarely goes like, totally off the rails, so to speak. There are a lot of vectors that are as yet totally undeveloped that seem like they're going to come online and cause a bunch of problems. So having this sort of SLA guarantee layer, validation layer, seems really smart in light of like prompt injection, for one thing. Like as users get more, generally sophisticated and kind of, savvy in their adversarial, attempts, like you gain a lot by having something like this like implemented ahead of time. Similarly, we've seen some really interesting things even in Bing where a user will change, or not even a user, right? This is where it starts to get weird. Like a site owner, we haven't even begun to see like what the SEO people are going to do in the AI search era. So the battle between search and SEO, the arms race there, I think is going to be made to look pretty pale in comparison compared to what is going to happen now that you can like try to trick the language model at runtime with whatever kind of content. Then there's all these like you've got model risk too, where you really probably do want to, as awesome as GPT-4 is, and my general strategy right now is like use it for everything, get the quality to an acceptable level, and then think about, maybe taking out cost or taking out latency opportunistically or as necessary or what have you. But that's going to come in due time too. And then people are going to be like, well, what about like, I heard like alpaca, whatever was just as good. And, we can just sort of drop that in there. But now you're just in a world where you have no idea what's going on, right? I mean, your OpenAIs, your Anthropics, like they have a certain SLA. And I think one huge misconception that people have is like that SLA sort of is an inherent property of language models, when in fact, like it's not at all. And they've worked really hard to get to the level that they have. And like, you definitely cannot take for granted that your, bootlegged llama fine-tuned on whatever is going to be, anywhere as safe or friendly to users. I don't know. I'm going on, but that seems really important. But it's all that stuff is just starting to kind of emerge from the mists. How much did that motivate you? Do you see other things like that, or what do you make of all that kind of emergent security stuff that you're kind of helping people get in front of?
Yeah. I think I think security is a big operational risk of working with these models, especially like prompt injection. I think we all kind of when Bing Chat was released, I think Sydney, we all kind of saw how easy it was to kind of manipulate these models in like specific ways. So yeah, I think like how I think about this is very okay. Like how do you decompose the problem, right? I truly think that this isn't a problem that would be solved by machine learning specifically. I think a lot of what OpenAI has managed to achieve is, built on like this concept of like scaling laws, where, like as you scale the data, et cetera, you just kind of start to see and scale the models, you start to see, emergent properties. But this is, just from like all of my experience working in machine learning, like these are fundamentally stochastic systems, and it's very hard to like, there's a big long tail of, like what these stochastic systems like can't have guarantees for, right? Like you cannot have guarantees. You cannot have data points for all of the different exciting and weird ways that people are going to use these models. And so as a consequence, it's very hard to like add that validation like from the model piece itself. And so security becomes, an essential thing, because that isn't something that you can leave like up to the stochastic system, right? You essentially need to have like more determinism like around it. And so my way of thinking about it is to kind of like break it down into like, okay, the model is stochastic, like what can we do around the model that then adds that, those like watertight guarantees. So for prompt injection, for example, like the things that are really exciting to me are both like on the input and output side, right? You sandwich the LLM API call with like, input validation, output validation, to essentially ensure that you have like multiple layers of security that, make sure that your model isn't behaving in ways that you don't want it to. So some of the ways I like, familiar with like some of the more exciting like new developments in, like protecting against prompt injection, but also, on the output side of things, like I think a lot of those corrections are like an input validation, but like on the output side of things, if you know that there's behaviors that you don't want this large language model to exhibit, it's possible to do that, as like secondary checks in terms of output validation, right? If you want, for example, if you have like known patterns of prompt injection that people tend to follow, you can do that on input validation to essentially make sure that there's not, you're almost like gatekeeping like queries and interactions that users can have to the set of things that you can kind of support. So I think like solving it's back to this problem of like kind of what are the like decomposing this whole problem of security into specific domains, specific applications, and then for those domains thinking about like what is the just like what is the end goal that I want my users to have, and then like adding constraints to filter out like everything that is outside of that goal, that is not kind of related to that goal. So like I would be very surprised to see if I for example like chatted with a bunch of teams who have been doing this, and like I think that's a common design pattern, right? Like where you can't simply rely on the LLM. Like there's a reason, for example, like we don't have like end-to-end machine learning systems, right? Like you kind of have like some sub-component be machine learning, and then some checkpoint that has like either human or like a more deterministic a component like verifying or validating the output of the machine learning system, and then like another downstream thing that may be machine learning, but decomposing it and like adding different layers of security on either end of like the ML system is like the pattern that most people, when they try to like productionize these things, will kind of like see happen.
Security in depth, defense in depth is definitely, I think, going to become really important. Another version of this too is models talking directly to other models in vector form. Seems like it's going to become a huge trend. We had the authors of Blip 2 on the show a while back, and that I think of that as such an emblematic foreshadowing of what's to come, where they're able to take a frozen vision model and a frozen language model and very quickly train a connector model that essentially converts the encoding of the image to something in some literally unspeakable thing in the language embedding space, in a way that then allows you to have like dialogue with the language model about the image.
I actually love that. Yeah, sorry to interrupt, but I love that example, because this like literally is like research that I'd done, in my master's, and that, I worked with some collaborators, and I have a paper about this that does like these kind of joint embeddings in language, in vision space for, I think we did this in the fashion domain, where you have some fashion embeddings and then some text associated with it. How do you project it into a single space, or into a single like, projection space, so that you're able to like figure out similarity between, essentially like using language, figure out like what are similar images, etc. So it's a body of work that is like pretty interesting, and like opens up like so many cool capabilities.
I mean, the fact that that's going to work seemingly across, I'm still educating myself on this, but I really just see so many examples of like, even just simple linear maps from one space to another, that people are kind of able to, now bridge these different encoded or latent spaces, whatever you want to, embedding spaces. I think that's going to be a huge trend that will bring a lot better performance out of a lot of systems, because like, why would you go through this natural language bottleneck
if you have a much richer representation of an image, or for that matter, a medical scan, or, a sound or whatever. Like, you have the sound of the bird in an audio file. You're not going to project that down into language long term, and be like, a sound of birds is heard or whatever, and then feed that into the language model. You're going to figure out how to represent that in the language models space, but in like a way that is truly unspeakable. That I just see so much force going in that direction. But then the obvious worry there is like, well, now you've opened yourself up to God knows what, like the space of possibility there is so vast. It's totally untestable. It's like incomprehensible on the input side. So what can be done about it? I think, again, this is like a really good answer. Like, start validating your outputs, people. This is really important. And it's only going to get more important. Like, I think one thing people are probably really underestimating is they can create a system today that behaves pretty predictably, and the world underneath it is going to change in such a way that it may start to expose their vulnerabilities over time. I mean, in some sense, software kind of always works that way. We've seen like Windows patches way downstream after launch, but I don't know. This seems a little bit different.
Yeah, I think it's a very interesting point. I think it's like this fundamental idea of like, more sensory, like input from more sensors. If you're able to have that and code that, I think that just leads to like better performance. And it's also like going back to this idea of like grounding that I was talking about earlier. Like, you have like some ML system that like projects it in some space. How do you make sure that that projection is correct or not? And if you have this idea of grounding where you have like, this other sensory input that is also supposed to be projected into something, you can use that as like you can use that as like self-correction or like self-verification systems, right? So we kind of like saw this like while I was at Drive AI, which was the self-driving startup that I worked at. I think we had this where the performance with using just LiDAR versus using, like if you have cameras as part of your inputs as well, in addition to LiDAR, you just kind of like have a better understanding of the state that the car is in. And you're able to, kind of like have better, just make better decisions overall. So I think it's a, in my opinion, I think it's a net positive thing because it allows us to also like enforce these guardrails, across like multiple dimensions, right? Because it allows us to kind of figure out like where things might break down and then add like checks and systems there in place. So yeah, I'm excited to see a world where we can have like all of these vectors embedded in the same space, and there's a lot of like interoperability between them. Yeah.
So essentially, you're describing a validation step that is in coherence of like semantic interpretation of different input signals. I'm trying to think of any example of that I've seen in the wild. I guess you're pointing to one in the self-driving car area. Maybe I want to just kind of throw a few other kind of safety, control, et cetera, sort of paradigms at you and just have you react to those, not in a like better or worse sort of way. I mean, I think obviously, again, defense in depth, like there's a place for probably all of these different things. Maybe in just kind of comparing and contrasting some of these other approaches to what you're building. Again, it can help enlighten people as to, how you're thinking about it and how, what kinds of use cases, your project is best suited for. So I've got a handful. One is most people listening to this will be most familiar with OpenAI, obviously. So their moderation endpoint, which briefly you can like take an output, bump it up against the moderation endpoint. It gives you like a flag of, hey, you might have one of these like finite number of, problematic content types. And then I believe you can really do with that what you will still. I don't know that they even enforce any, particular action downstream of the moderation endpoint. But essentially you're classifying stuff into one of these categories. That's obviously pretty simple. So where do you think that kind of falls short?
I think it's great. I think it's very finite in scope. So if you were to take something like that and then expand that out into, like any use case that you want to verify or validate, but, that is like at least programmatically verifiable or verifiable with the machine learning model, flag specific things within that output that may be problematic for that. And then also allow you to configure how you want all of those, invalid outputs to be dealt with, right? I think that is how I think about guardrails. So moderation. So if you think about moderation, I think specifically like profanity filtering, etc., is like one of the validators out of like a number of validators within the library. So it, you take some LLM output, you give it to that profanity filtering validator, it'll tell you whether there's profanity or not in your LLM output. And depending on how you configure that validator, it'll also like correct that for you. So for example, generate that text without profanity, or maybe just filter those sentences that have profanity in there. But you can just take that pattern and apply it across a bunch of other use cases. So if there's code that is generated that maybe is incorrect or is not executable, you can do the same thing for code. If there's like summaries that are generated from some source text, but those summaries are incorrect or invalid for some reason, you can do that. If there's like structured data that you've extracted, which is like specific parts of it are incorrect, you can basically apply that same paradigm. So it's taking that moderation endpoint, but making it like a very general, very extensible thing that you can use.
In practice, what do you see people doing most to fix on fail? Like you gave a number of different kind of choices there, where one could be like, pop an outright error. The other could be like rerun the whole call and just like hope for better the second time. But you're getting pretty granular in between as well, with like maybe just fix a little bit or like snip the profanity. How would you like advise people to think about which option they should take in that moment of a problem? And what do you see people actually like doing today in the community?
I think that's a hard problem to answer, because like I can't tell people what their what their pain tolerance is like for their applications, right? Like I think fundamentally, there's like some cases where you're like, oh yeah, if this doesn't pass, like this LLM output is of no use to me, right? And so I want it to either be corrected or just like filter it out. I can't use it in this like in between state. And so re-asking is like one of the things that is pretty valuable. Like it allows you to kind of like just from the user perspective, it's like I don't want to say one shot, because there's like it's an overloaded term, because ML one shot, etc. But like it's like from a user perspective, it's a single API call that like on the back end might make like multiple API calls, etc. to the large language model, but like give you like either a corrected output, or it'll tell you like, hey, this is just like incorrect and I can't handle it. So for very important use case, or for very high stakes use cases where if a validation check fails, you can't use it, I think like re-asking is probably the most effective thing that I see people use a bunch. I think like filtering is another one. So specifically for like summarization or for profanity, etc. If there's like some sentences that don't aren't information dense or that have profanity, you would be able to have like that granular control of like filtering out those specific things. And I think like another one, which is like the default setting if you're using Guardrails, is like a no-op. So essentially you would still run all of the validations on an LLM output. But you would only like, if validation fails, you wouldn't do anything. You would just like return the output as is to the user. So same as if they were using an LLM without Guardrails, but it would just like log everything that went wrong. And you can access that log and like figure out, do I want to iterate on my model or my prompt or something, using that. So I think those are probably some of my favorite ones, but like there's also like raise an exception or like deterministically fix it if it's possible to deterministically fix. So yeah, there's a suite of options within the framework.
OpenAI's, we'll go with OpenAI's first. They also recently with GPT-4 launched this Evals library. I'm sure you've studied that a little bit. I guess my surface understanding is that's more of like architected as like a benchmarking suite versus like a runtime aid. But maybe, what have you learned, or what did you think was smart in the Evals implementation or approach to validating language model outputs?
Yeah. I think I really like Evals. I think my interpretation is the same, which is that it's like this offline, benchmark that allows them to internally test out how well, their LLMs are doing for tasks that people care about. And so I think like one of my favorite things about it is just I guess this is maybe not technical, but maybe more from like a product or go-to-market standpoint. I really like how they, it's almost like this way to crowdsource like how people want to use their large language models, right? Like all of the ways that people are using it and like all of the ways that it's going wrong. Take that and almost make it part of it, like your training data set or your evaluation framework, so that the models themselves are, are primed to serve those use cases better. So I think that's probably my favorite thing. I've seen like other folks use it to just like scour through it and maybe figure out, interesting prompts that they can borrow. So I've seen some people do that, which is pretty interesting, which I think is like a nice way to like mine that library. But that's probably the, I see it as a totally different framework, basically.
I thought it was a nice touch also that they tied or essentially created a separate lane for GPT-4 API access for folks who contributed to the Evals library. How about like Anthropic's constitutional AI approach? Again, it seems like there's that's obviously a training protocol as compared to a runtime validation, but do you see commonalities there, or have you taken inspiration from their approach?
Yeah, the constitutional AI stuff is interesting, but I think it's back to like some of the things I said earlier, which is that like it is essential to have like deterministic checks, right? Deterministic post hoc validation, because like just by training itself, like the models are not super sufficient. So I think like runtime verification, runtime validation is like the most exciting kind of problem to me. So that's how I think about it. But it is pretty interesting. I think this other aspect of it is just like configurability, so also a similar theme that I touched on earlier, but being able to configure, like what correctness means to you and like enforce that specifically, rather than having like this globally understood, agreed upon like standard of correctness. So I really like that world where like developers like have that agency to configure what that means to them. So I think that's also being able to do that in this post hoc setting, where you don't have to go and train a model every time your definition of correctness changes or every time your use case changes. I think is like it like opens up access to a much broader audience.
Yeah, I feel like there's an opportunity though to sort of bring the constitutional critique to runtime. I listened to the guy, his name is escaping me right now, but one of the lead authors on the diplomacy paper, the Cicero model that came out of Meta, he was describing a general strategy of like, how can we bring more compute forward to runtime? Like the old systems of like, Deep Blue and chess was like super intensive, compute at runtime, to the point of being like borderline largely a tree search, more so than an AI, or as we think of it today anyway. But like with our language models, it's not been quite as obvious how to do that. And it seems like, again, this sort of framework of, rather than lean on all that embodied compute and training, like bring some of it somehow more forward to runtime and, apply like all these checks that essentially like the more compute you can spend, like the more likelihood you have of getting like really good output, essentially is his mega, observation. You talk about like deterministic, but some of these things, they're still not really deterministic, right? Like the more I critique, like I still have this kind of inherent, it's layered non-determinism, right? More than, which hopefully kind of limits my problems, but still there is some, like in most cases, right? There's still some amount of stochastic stuff that is not like reduced.
I think that's a very good point. And I should like clarify, I should qualify what determinism means. So I think there's essentially different ways to like evaluate or to validate outputs, right? And I think like basically one of those ways is like taking an LM output, creating a new prompt that asks GPT-4 again, like, okay, is this output correct or not, given these criteria, and maybe give me like a yes or no, or like maybe some binary response that allows me to assess this, right? And that is like one way of doing validation that is not deterministic at all. But it is, like additional layer of security. But I think like there's also like a bunch of other techniques and like, other like validation rules that people can use. So some of them are more kind of like rule based or heuristic based. Some other of them are like, not using LLM APIs, but using, like maybe smaller, high precision models that are, like trained on like subsets of data. So even if they're not deterministic, they're like trained on your own data. And because you have control over the model, you can, maybe do things like set random seeds, etc. So that you essentially get, even if it's an output that is, like generated by a machine learning model, it's an output that you have control over and you can control its randomness on, right? Either in terms of like changing the seed or changing some of the parameters, or just like being able to like generate or throw more training data at it. So that both of those frameworks are, like one is like purely deterministic, and then one is also like more deterministic in terms of, being able to control randomness. So when I say deterministic, I'm truly referring to, like an ensemble of like all of these techniques. And so some of them are, basically all over the map in terms of like what their randomness kind of looks like. But that was a good like little catch. Yeah.
One obvious question from a developer standpoint is, what overhead does this create? And, you can measure that in a number of ways, right? Like token overhead, which is cost overhead, maybe like complexity overhead, latency, increase, and then maybe some like just tensions also in a product experience. Like I think about the Bing experience, where fascinating, honestly, that one of the biggest corporations in the world went with this as their approach. They spit out the token, in a streaming token by token way, and then retract it from you if they determine that it went off the rails. So like, I mean, that is crazy to me that Microsoft like launched with that paradigm. I do get why, of course, because like people don't want to sit there and wait for the whole thing to be generated before they can start to see what's happening. There's a really powerful draw to the streaming experience. So much so that, Microsoft did this, but like, it's crazy that, the biggest corporation, one of the biggest corporations in the world is willing to knowingly like set up a system where they're gonna sometimes emit some toxic content or whatever, and then I'll just kind of swipe that
swipe it off. Yeah.
We're in a brave new world for sure. So yeah, I guess all those dimensions. How do you think about kind of overhead, and again, how would you kind of guide developers toward minimizing that overhead? Are there things that could be done in parallel, or what's kind of the smart version of this, so that because a lot of people are going to be like, okay, yeah, but the CEO says we can't wait for that.
Yeah, I think that's really it's a really good question, honestly. Interestingly, before I start talking about how I think about overhead, you would be surprised by how for specific applications, like if you're not in the chatbot world, like how comfortable people are with latency, as long as if they're getting like high quality output at the end of it. So when I was kind of initially building this, like latency was a concern, and like some of the design decisions I made, support that hypothesis, like re-asking, for example. There's not piecemeal re-asking, like I aggregate stuff and then re-ask, so that it's a one-shot kind of like request. But people are pretty okay waiting for, if they're in this world where correctness matters to them, people are pretty okay, like tacking on some additional latency in order to have that correctness. But with that said, I think like overhead is a pretty important question. I've actually found like token overhead is an interesting one, because I found like this interesting balance between, like how efficiently can you like write a prompt if you're using the structured prompting strategy that Guardrails offers, versus how efficient are your prompts when everything is in words, right? And so like for some use cases, interestingly, I have seen that like being able to structure your prompts, even if you would think that it's more tokens, it's actually more efficient, because like all of that structure and all of that those constraints, which are like now maybe in symbols or in some domain specific language, end up being represented in like words, which is way more just way more expensive in some cases, right? And that's a similar, like I've seen that with complexity as well, where if you're trying to get your LLM outputs to be like structured in some way, or to be to have some behavior, etc. Right now the only way to do it is to like prompt it yourself and like do a bunch of prompts, etc. But Guardrails kind of like abstracts some of that complexity and some of that exploration that you have to do away from you, right? Because here's this DSL that like is tested and like works across a bunch of these LLM providers. And you essentially, as a developer, you don't have to think about like, how do I write a prompt that will give me this output that's structured this way? Like I just write it in this like known way. And that, is like almost easier in terms of development. Like I have tweeted this some time ago, and also a plug for my Twitter. Follow me at Shreya R if you don't already. And I basically talk about guardrails and AI all the time there. But I tweeted this, which is that like, even if you're in this setup where you don't care about validation, if you just care about like getting structured outputs, like it's a pain to kind of like think about how to do that, right? So just use guardrails for like getting those structured outputs across like LLMs, and like it's useful in and of itself, right? Because you don't have to like write prompts and like iterate on prompts, etc. So
help people understand a little bit more like that complexity that you're taking out and how you're doing it on the just first question of like, can I get the desired format back?
Yeah, good question. So I think how guardrails kind of like the entry point for developers is like creating this spec, which is a markup language where you're able to specify here's like an output schema, right? So if I want an output, here's like all of the different components that I want in that output. If that's a JSON, then you're able to kind of configure that. If it's just a string with like some additional validation on top of it, like maybe it's just SQL string that you're generating and you want some additional validation, you're able to kind of configure that, right? But in this case where, but that is like totally separate from your prompt. That is just you thinking about like, what is the output that I want, and like how do I write that output in like a schema definition perspective. In the Rails, so Guardrails basically has Rails specs, reliable AI markup language. That's the specification framework. And so in a Rails spec, in addition to the output schema, you can also have like a prompt separately. And then all you need to add on the prompt essentially is like the high level task description, right? Because everything that describes like, make sure my output is this way, and make sure my output has these constraints, and make sure my output is formatted that way. All of that you do in a schema, which is like a specific, like it's a programming language, right? So you can think of it in terms of like, if you can write like XML or you can write markup, you can write that, and you don't have to convert that into English and then, do a bunch of experimentation to make sure that your LLM API will like understand what that means. So it allows people to like basically, it allows people to only think about like the pain of prompt engineering essentially goes away a little bit, and it allows you to think about like interacting with these LLMs in a more programmatic fashion to some degree. So that's that's the complexity that gets that Guardrails kind of takes on. So one of the exciting things about that is that the contract between the user and Guardrails is basically the spec, right? And then it's Guardrails' job to translate that spec into a prompt. So the user gives, like a high level prompt and everything, but, the output schema definition is translated into a prompt based on Guardrails. So if you work with these LLMs, you would know that, they basically like change, the version internally gets updated like all the time. And as part of like the behavior of the large language model changes, right? And I've experienced some of that as I've been building this library, but you would essentially kind of find that like, even if the model version changes, as a developer, you have the same Rails spec, and then Guardrails just like compiles that Rails spec into different prompts, depending on, like what is most effective for a specific LLM. So I think like that is also, like from a developer point of view, you don't have to, wrangle like model version updates and like model quality issues to some degree.
That sounds really useful. I was just doing some stuff yesterday where I'm doing some task automation, and I used the format trick, right? Everybody kind of who uses language models much comes across the format trick, use this format in the response. As far as I know, that came out of OpenAI. As far as I've been able to track that back through Riley Goodside, who like very much popularized it. He attributes it to Boris Power, who's at OpenAI. Before that, I don't know. Or maybe Boris just came up with it on his own. But I do run into this stuff where I'm like, well, how intricate do I really want this format to be? A lot of times I'm just like, use this format, just like XML open tag, content, XML close tag. That way I can at least kind of easily just use a regular expression, just kind of parse out whatever's within those tags. And then if it has a prefix or a suffix or an I hope this was helpful to you, whatever, I can like get rid of that cruft and have what I want. But then I usually haven't gone that much farther than that, because I'm like, then I'm getting into like hand coding XML and like the playground or whatever. And that's not great. So right off the bat, I think that is maybe something we underemphasize at the beginning of the conversation, is just like, there's just a straight convenience factor associated with, at least from a developer standpoint, being able to write something in a little bit higher level abstraction and have the thing kind of translate to, a more detailed prompt that will get you the parsable result that you want.
No, yeah, totally. I kind of found that as well. When I was doing a lot of my prototyping, I had prototyped it with GPT-3. And then I had a similar experience with, I think anybody who's worked with GPT-3 and 3.5 knows that, you have like, here's the output you were looking for, and like, hope that was helpful, etc. Like all of these statements, right? Which are like, oh, just give me the JSON, which is what I want. And then I think like with Guardrails, since release, I've had like a community contributor actually like push this effort to, like add instruction tags and do a bunch of experimentation to make sure like what works well with GPT 3.5. And so from a developer standpoint, you write like one spec, and then depending on if it's GPT 3 or 3.5, it basically like compiles a prompt a little bit separately, so that it just works. Like I think even with GPT 3.5, I've had a bunch of people testing it out, and they just get the thing that they're looking for without a lot of that extra filler text that maybe that makes it not work as well.
Yeah, it's interesting that you are also then translating that to other models, which the angle that I was going to mention a second ago was, it seems like there's a dynamic here where, as people kind of try to think about like, where's all this going? How's the market going to shape up? Who's going to lead? Are we going to have like one AI to rule them all, or is it going to be many or so an oligopoly of large language model providers? Oh my God! So where's this all going? One force that I see kind of pulling everybody in line with OpenAI is just the fact that all of these things are getting developed against OpenAI's state-of-the-art behavior at the time, almost like across the board. And so then if you're a different large language model provider, if you're an Anthropic or a Cohere or a, Google or a, Alpha out of Europe or like whatever, then it seems like you have a really strong incentive to basically try to be as much like OpenAI as possible when it comes to like supporting all these things. But then that kind of just sounds like, well, then how are you going to compete on that, right? If you've got to expend all this energy to basically just make sure that like people even can switch to you without things that they're kind of currently assuming will work breaking, that's not a great position to be in, to be spending all your time just like trying to catch up in that way. But I don't know that there's any way around that for other providers. So do you see that dynamic similarly? And does this experience like lead you to think that we may see kind of concentration, if not necessarily of providers, at least in terms of like how language models behave?
Yeah, I think that's a really great question. I do think I'm pretty, like, I personally believe that there would be a big diversity in terms of model providers. I think like we are in this almost, it's kind of insane to see just from like, I've worked in ML my whole life, but or my whole adult life, but it's kind of insane to see just the amount of like activity and excitement around this space. Like there's people training and fine tuning deep learning models that weren't even in the space like a few months ago, and that's really awesome, right? And that amount of like demand like makes it so that there's more need and more providers that will come up. I had like people who were like, oh, I really like Guardrails, I really like OpenAI, but it's just too expensive for what I'm trying to build. And so can you make this work with, an open source model as an example? So I do think that we're going to see a lot of that proliferation happening of, great performing models from like different price points, different latencies, different providers, etc. So I'm pretty excited about that world. I think the other interesting aspect of this is that like, because a lot of this was unlocked by OpenAI, we're in this space where people are, building these frameworks, etc., around what is the most performant provider, what is the most performant model. And because like those frameworks are maybe like indexing too highly on OpenAI, like there's, this incentive for other model providers to, offer interoperability with for those specific functionality, right? So I do think that like the standards are evolving at the same time as like the models are getting better. So there's this like interesting kind of dynamic between them. So at least for the foreseeable future, there's like this big incentive for other model providers to also, provide similar functionality, or at least not have regressions, right? So that incentivizes people to, like maybe switch over to them for a variety of reasons. But I do think that like just the pace of innovation means that, there will be some just like a more level playing field at some point, and then it'll be very interesting to see like what are the specializations that different model providers offer, or even like with different open source models, like what that specialization ends up looking like.
Okay, here's my 3 quick. You can answer these quickly or not at all, whatever as you want. But I typically, if there's time, I usually ask these 3 final questions. One is favorite AI apps, experiences, tools, whatever that you are loving that you would recommend to others.
I'm going to be very basic and say Copilot. I think Copilot is awesome. I use it extensively, and I recently had to set up my dev environment from scratch and didn't have Copilot, and I was like, oh, what am I missing? Why am I coding slower? So yeah, definitely Copilot.
I can totally relate to that. When they went paid and it stopped working, I was like in a panic until I realized that I could just pay for it and make it come back. But yeah, it was like, I'm not going to be doing this without this now, am I? That's like not to be endured. Okay, second one, hypothetical situation. Sometime in the future, 1 million people already have the Neuralink implant. If you get one, then you can control your computer devices with your thoughts. Would you be interested in getting a Neuralink implant at that point?
I would not. I can imagine that, like, I don't know, as a weird like straw man. What if I'm in like a presentation or something and I'm controlling my laptop with my brain and I get distracted, right? Like, does that mean that my slide deck now is on like whatever I'm distracted by? Like, I think there's there's again like having guardrails and like having layers of security between thinking versus like something being executed on a different system. I think it's important to kind of have like some filtration mechanism there. So I would skip on it, but I would be very excited in that world. Like I would like inhabiting that world, even if I'm not actively participating in it.
Great answer. I love it. Final one, just zooming out, as wide as you can, and thinking as far in the future as you have any sense of what might happen. What are your biggest hopes for and fears for society at large as this AI moment continues to unfold?
I think it's a great question. Let's see. I think my biggest concerns, once again, I don't think I have any special insight here, but I do think like job displacement is something that I think about quite a bit. And thinking about, like what are the, just like what are going to be the, what is the amount of work, that would still be valuable in this future, where a lot of knowledge work can maybe be at least assisted, or like a lot of knowledge workers can be made like more efficient, right? And than what they are like today. So what does that mean for the future of work? I think that is something that I think about. And let's see, I think a hope is that I am able to live a life where I just don't have to do any of these like mundane things that end up taking so much of, our parts of life. So in the future, like maybe I don't have to do my own taxes, and maybe, I don't have to book my own flights. I can just say like, book this flight for me at this date and just find me the best price, etc. So being able to, like automate away a lot of those parts and then just do like whatever fun parts of life are, I think like that would be something that I'm excited about and hopeful for. Yeah. Go check out the package if you're building with large language models, and if you're facing like any issues where you're like, I was just working and it's not working anymore. How do I kind of fix that? Check out Guardrails follow me on Twitter.
Yeah, it's a beautiful vision. We can all hope for it. Shreya Rajpal, thank you very much for being part of the Cognitive Revolution.
Yeah, absolutely. Thank you again for inviting me. Really enjoyed spending my afternoon chatting with you.
Omneky uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omneky so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.